Hello, mom. I'm Harshit from DBMS class. I'll be explaining about my project that is predicting breast cancer using supervised learning algorithm and comparing their efficiency. I did this project along with Jacinth, Ebenezer, and Sandhya. So we basically did this project to help predict cancer, as cancer can kill multiple people, and predicting it ahead of time can save lives. So a data set has 32 features, and some of the major features are radius, texture, perimeter, area, smoothness, compactness, concavity, and symmetry and fractal dimension. All these features have three types, that is mean, standard error, and worst. So first we import various libraries. The first is pandas and numpy. So these two libraries are basically used for data cleaning and manipulation. That is, they help us manipulate our CSV file to delete unwanted data or to leave data points that have missing values and such. The next is matplotlib and cbond. Matplotlib and cbond help us draw graphs for the data, and cbond is used to draw heat maps for the data. It helps us in comparing the correlation between various features within the data. And the next is sklearn. Sklearn is used to do the prediction and fitting of logistic regression. It has all the machine learning algorithms in it. And stats models is used to give us confusion matrices, the mean, median, and various other statistical analysis of our data. So first we read our data and just see what all columns do we have. So you can see we have ID for each patient and diagnosis. The diagnosis is either M or B. M refers to malignant and B refers to benign. So then we see the last column. The last column is unnamed 32. It has various unwanted data which is not necessary in our prediction, which we will remove it later on. And then we just see the various data types, the data type of each feature within our data. So you can see almost all are float type except the last column. df.drop unnamed 32, it drops the whole column, and df.data type shows the remaining columns. So once we drop the column, we try to understand our data set and how the features are related to each other. We try to see the relation between various features in the data. So we draw the graphs for each of these features. So here we can see that many features have a similar type of graph, meaning they are correlated and the data is recurring. We don't require data that is repeating or has the same meaning again and again. So after this, we find out the correlation between various data features. Correlation is nothing but it is a measure to find how similar the data between two features are. So here we use cbond to draw a heat map, 1 being the hottest and 0 being the coolest. So if the correlation value between two data features is 1, it means that there's too much common within the data between those two features, and there's too much recurring data. So either of those will be deleted later on. So we delete based on our previous analysis of correlation and looking at the graphs of various features, we can delete all the worst, the columns named worst, because these columns are almost similar to columns with the name mean. That is, the radius worst and radius mean are almost similar, and thus these columns are not required, so they're all deleted. And the columns named perimeter mean, perimeter standard error, area mean, and area standard error are all recurring data, meaning perimeter and area are dependent on radius. So since they both depend on the same variable, it is recurring. It is not necessary to have both of them, and any one of them is enough. So either of those are deleted. And the same way, concavity mean, concavity standard error, concavity points are all similar data types, which are all deleted using the df.drop command. After deleting all the unwanted tables, we can see the columns that are remaining here. So now we draw our heat map again to see how good our data set is. Now we can see that the heat map is way more lighter than before. indicating that there is not much repeating data or much correlation between various data features. So now we will build our model using the sklearn library. So we first split our data into testing and training. This is done to avoid overfitting. Overfitting means uh, when you when you build a model on the same data and test it on the same data, the algorithm already knows these results, and thus it predicts the predictions perfectly, meaning there's an exponential raise in accuracy, which is actually not correct. To avoid this, we split the data into testing and training. So here we take 70% of the data for training and 30% of the data for testing. So we can split the data as 70 and 30%. And after that, we generate the formula. The formula is basically the sum of all features. And after that, we use the sklearn library to pass our parameters on the data set and then build a model. Model.fit is a library from sklearn that helps fit our data, and it assigns weights and stuff to make the accuracy better. After doing that, we predict our data. That is, we give our algorithm the testing data and see if its prediction are proper. So after taking these values, we convert these into Maligant or Benin. To convert those, everything below 0.5 is taken as Maligant, and everything above 0.5 is taken as Benin. So we can see that here our probabilities are converted to M and B. Once that's done, we create a confusion matrix. Confusion matrix is basically a matrix with the values of true negative, false positive, false negative, and true positive. And once that's done, we print our confusion matrix and various precision and recall scores. After that, we print our confusion matrix. And we can see that 111 plus 54 are proper, and only 6 data points are predicted wrong. So based on that, we calculate our accuracy as true negative plus true positive divided by total observations into 100. And so we can see that our accuracy is about 96.5%. And after this, we will compare our accuracy with another data mining algorithm, that is k-nearest neighbors. So k-NN algorithm. Now here for this algorithm, we require only few libraries. We import NumPy, Matplotlib, and Pandas and random. NumPy and Matplotlib are for data clean. NumPy and Pandas are for data cleaning and deleting unwanted data. Matplotlib is for drawing the graphs and data visualization. We used random here because in the previous model, we took 30% and 70% to be testing and training data. Here, when we use random, a random 20% and a random 80% of the data is taken. That is, not only the first 80% is taken for training, it can take 80% from any random places in the data. So the function, the library random allows us to do that. So after that, we see our data set to understand how our values are. We can see that few values are missing. These values are replaced to be minus 99999. This is because if they are not highly negative, the algorithm would treat them to be accurate values or proper values. It would treat them to be correct values. And if it treats them to be correct, our accuracy could vary largely. We would get wrong accuracies. To make it understand that these are wrong values, we give it a highly negative value. And after that, we use the function random, which is from library random, to split our data into testing and training. So in this data set, the Benin cases are classified as 2. The output for Benin cases is 2. And for Malian cases, it is 4. So we classify it using dictionary. We classify all the Benin cases into 2 and all the Malian cases into 4, as those two are the keys to those. 2 and 4 are the keys for this dictionary. And once this is done, we do the prediction with k-NN. So first prediction is in k-NN. Here we calculate the Euclidean distance. Euclidean distance is basically the distance between one point and a point to be predicted. So all the features, all the points in our data set are considered on a graph. So now we use KNN algorithm. So now we use KNN algorithm to predict our data. So in KNN, we basically find the distance from a point to be predicted and to the rest of the data. So np.array of features contains our training data, and np.array of predict contains our testing data. So so Euclidean distance and np-linlag.norm calculates the distance between these 2 points. And once calculated, it classifies them to be a part of benign or malignant based on the distance, which is based on its distance from these two. And so, for example, if a data point is closer to benign, it will classify this data point as benign, or if it's closer to malignant, it will classify it to be malignant. And based on that, it will give it a value of 2 or 4. After that, we test our data for accuracy to find out its accuracy. This is the sample testing. We use a small data set to go on. The actual testing is at the bottom. So we use our testing set again. And so now we have actually found the results for our testing set. So we compare this with the actual results and calculate the number of correct results and the total results and display accuracy as correct by total into 100. You can see the accuracy is about 95%. So this accuracy can vary sometimes because the randomized functions generates different data.